Every secure login in your organization relies on one invisible thing: trust. In this course, we'll connect ADCS, ADFS, PKI, and Microsoft 365 into a single coherent identity strategy and outline concrete steps to modernize without breaking what already works. Traditional firewalls assumed everything inside the network was trusted and everything outside was dangerous. That clean boundary is gone. Users now connect from anywhere, on any device, to apps that may live entirely in the cloud. In this world, identity becomes the new perimeter. Security decisions center on who or what is making this request and can we prove it cryptographically. That shift is exactly where Active Directory, PKI, and Federation services turn into strategic building blocks. To design a solid identity solution, you need to see how PKI, ADCS, and ADFS relate, but are not the same thing. PKI is the big picture, the mathematical and policy framework that defines how trust works using public and private keys. ADCS is Microsoft's concrete implementation of that trust, issuing and managing X509 certificates tied into Active Directory. It's a tier-layer asset, so as consultants, we treat it like crown jewels. ADFS sits on top of this trust fabric. It consumes certificates to issue tokens and share identity claims, but brings high operational overhead, making it a frequent candidate for consolidation or cloud replacement. To understand ADCS, ADFS, and Microsoft 365, we first need to unpack what a certificate actually proves. A digital certificate is a cryptographic passport. It contains a public key that anyone can see, and it implicitly points to a matching private key that must stay protected, ideally in an HSM. The certificate also encodes what that key is allowed to do through extended key usage, such as client authentication or smart card logon. The subject alternative name is where identities are bound. If this field is misissued or abused, attackers can gain unexpected privileges. Finally, the CA's digital signature is the wax seal. It's how PKI asserts, this key really belongs to this identity, and you can trust it across the network. Active Directory Certificate Services is essentially your in-house certificate factory for the entire forest. Active Directory holds a configuration partition that publishes CA information and certificate templates. Those templates define what a certificate can be used for, how long it's valid, and who's allowed to request it. When a machine or user enrolls, AD points them to the right CA. The CA evaluates the request against that template's permissions, and, if it passes, issues the certificate. All of this is locked down with role-based access control, so only specific CA admins, auditors, or backup operators can touch sensitive functions. Enterprise root and subordinate CAs then form a hierarchy that spreads trust and limits blast radius if one CA is compromised. Active Directory Certificate Services often becomes an unexpected path to tier their compromise. A classic abuse is a misconfigured certificate template, especially one that lets users control the subject alternative name while also granting client authentication. With that mix, an attacker can enroll a certificate that effectively says, "I am a domain admin," and domain controllers will trust it. To harden this, treat every CA, template, and enrollment policy as a tier-ner asset. Lock down local admin to tier-ner accounts only. Any template that allows custom subject information should require explicit manager approval before issuance. And wire in monitoring. Watch certificate services event logs for unusual SAN values, high-risk templates, and sudden template changes, and feed those into your SEM for alerting. Now let's layer in ADFS. Think of it as a trust bridge between your on-premises Active Directory and Microsoft 365. Users still authenticate with AD, but ADFS converts those credentials into signed tokens that cloud apps can understand and trust. The web application proxy sits in the DMZ, accepting external sign-in traffic and safely relaying it to the internal ADFS server. ADFS then issues a token, cryptographically signed with its token signing certificate. Microsoft 365 validates that signature instead of talking to your domain controllers. All of this rides over HTTPS using TLS certificates that public CAs trust. So PKI underpins two things: the secure tunnel with TLS and the proof that each token really came from your ADFS. ADFS delivers powerful federation, but it brings real operational overhead that you need to plan for. On the networking side, you must open 443 for federation traffic and 49,443 if you want client certificate authentication. DNS has to use A records. C names will break Windows integrated authentication, and cause hard-to-trace sign-in issues. Load balancers also get opinionated. They can't terminate TLS, SNI has to be preserved, and you often need IP-based affinity instead of simple round-robin, or users lose their sessions. ADFS is tightly bound to Active Directory, so you need supported Windows Server domain controllers and a modern schema version. And every farm depends on token signing and token decrypting certificates. Lose or mismanage those keys, and your entire trust fabric collapses. In a legacy hybrid design, everything starts with PKI. Active Directory Certificate Services issues the TLS and token signing certificates that ADFS needs to function securely. Your on-premises Active Directory remains the source of truth for identities, and Entra ID Connect simply synchronizes those users and groups into Microsoft Entra ID in the cloud. When a user tries to access Microsoft 365, the request is bounced back to ADFS. ADFS checks the user against AD, creates a SAML token, and signs it using the ADCS issued certificate. Microsoft 365 then validates that signature. If it trusts the certificate chain and the claims, access is granted. Legacy federation with ADFS seems familiar and already paid for, but it quietly taxes both security and operations. It expands your attack surface. Exposing WAP, ADFS, and ADCS into the DMZ gives external attackers multiple paths into your core identity systems. It also creates a single fragile trust anchor. If the token signing certificate is stolen or mismanaged, an attacker can mint valid tokens and walk straight past access controls, the classic golden SAML scenario. On top of that, it's operationally heavy. You're babysitting connectors, hardware, and certificate life cycles. A missed renewal or local outage easily becomes a tenant-wide incident. All of this is why many organizations are actively moving away from legacy federation toward modern cloud-based trust. When you design authentication today, the key decision is whether to keep investing in legacy ADFS or move to Entra ID. ADFS gives you control, but it comes with a heavy infrastructure footprint, complex patching, and a model where your team owns every outage, failover plan, and security gap. Any availability or DR improvement means more hardware, more configuration, and more operational risk. Entra ID shifts all of that to Microsoft's cloud. You offload servers and databases, gain automatic global failover, and plug directly into zero trust, conditional access, and real-time token protection. From a consultant's lens, the strategic move is to reserve ADFS only for edge cases and standardize new solutions on Entra ID. Think of your identity platform evolving along this S-curve. At the beginning, you simply attach to the cloud. Tenants are created, identities sync from on-prem AD, and ADFS still drives authentication. Next, you move into a true hybrid state. Devices are hybrid joined. Self-service password reset and initial SaaS integrations rely on Entra ID, but AD and ADFS remain central. In the cloud-first stage, new apps and devices join directly to Entra ID, and you actively migrate ADFS workloads. From there, you deliberately minimize Active Directory, keeping only edge use cases. The end goal is 100% cloud. No on-premises identity footprint, with PKI-aware apps integrated into a fully cloud-native lifecycle. Migrating from ADFS is a consulting project you should run as a phased program, not a one-off change. Start by treating discovery as an audit. Catalog every relying party, protocol, claim, and certificate dependency. This is what keeps you from breaking that one forgotten line of business app. Then, design your new foundation in Entra ID. Choose password hash sync or pass-through authentication, validate domains, and plan how PKI, certificates, and MFA will work in the cloud. After that, cut over in waves. Move low-risk apps first, enforce conditional access, and retire ADFS MFA adapters as you go. Finally, monitor sign-ins, fix edge cases, and only then decommission ADFS servers and close firewall holes. To keep ADFS and Microsoft 365 reliable, you can't manage certificates with spreadsheets anymore. A modern approach is certificate lifecycle management that ties together three core pieces. First, Enterprise PKI. Your internal CAs or cloud CAs issue certificates through standard protocols like SCEP or ACME, so any workload can request and enroll certificates consistently. Second, Azure Key Vault protects the private keys. It acts like a cloud HSM, centralizing key generation, storage, and rotation, so keys never leak to admins or scripts. Third, Azure Event Grid drives automation. Expiry events trigger renewal workflows, update bindings on ADFS, application proxy, or exchange, and confirm compliance without manual effort. To wrap this up, think of your ADFS and ADCS estate as a living system that must adapt to two pressures: modern attackers today and quantum attackers tomorrow. First, move from static, once at login validation, to stateful validation. Authentication tokens should be short-lived, continuously checked, and revocable in near real time. That way, when an identity is compromised, you can actually kill its access path instantly. Second, push hard on phishing-resistant MFA. FIDO, 2 keys and passkeys anchored in Entra ID give you strong, certificate-backed authentication that's very difficult to replay or proxy. Finally, build quantum-safe PKI. Start inventorying algorithms and key lengths and plan upgrades so your certificate chains can be reissued with post-quantum ready cryptography as standards mature.